So guys, today we are going to see in detail another factor which is going to affect the rate of reaction. That is, we are going to see a factor that is how does your temperature is going to affect on the rate of reaction. If you remember, when I was dealing with the factor, I gave you the hint. What was that? That is, as you are increasing the temperature, what happens? The rate of the reaction also increases. So we have a hint. What is that? With increase in temperature, of course, the rate of the reaction also increases. Yes? But in this part, we are going to detailedly analyze the question how. That is, how on increasing the temperature, the rate of the reaction gets increased. So before going to that one, I want to make you specify that. Remember, whatever the temperature part is there, that is directly related to your rate constant. Okay. So why I am saying it? Because whatever the temperature role is there, that is mainly influencing your rate constant. And one most important thing you have to remember, that with the increase in the value of the rate constant, your rate of the reaction also increases. So if you are remembering, when I said the factor, I mentioned over there that what? With the every 10 Kelvin, if you remember, you can just turn your pages and just you look after. With every 10 Kelvin rise of the temperature, the rate of the reaction nearly doubles or triples. Yes. So we are going to see it. How is it possible? Okay. So now let us go into our topic, that is effect of temperature on the rate of the reaction. So remember guys, the quantitative effect of temperature, on the rate of reaction, is measured using temperature coefficient. Very much important. Temperature coefficient. So what they are saying, whatever the quantitative approach is there, that is the calculative part of your rate of the reaction, which can be calculated or which can be measured using a concept of your temperature coefficient. Then you can ask me, so what is this temperature coefficient? As I said, your temperature has a direct influence on the rate constant. Here also in temperature coefficient, we are going to deal with respect to the rate constant. So now we are going to see what do you mean by this temperature coefficient. So what does your temperature coefficient say? Basically, it is a ratio. It is a ratio of rate constant. It is the ratio of the rate constant of a reaction. Measured at two different temperatures. Remember, measured at two different temperatures. Okay. Differing by 10 Kelvin. You just mark my words over here. Now, temperature coefficient is defined as what? It is a ratio of what? Rate constant. When it is measured at two different temperatures, and what is the difference between those two temperatures? Is your 10 Kelvin. Then how can I write, for example, if I take it as a TC as my temperature coefficient? Remember, it is the ratio of the rate constant. Of course, I know it. So if one is measured at T plus 10 Kelvin, then another will be measured at T Kelvin. So it is a ratio of the rate constant of a reaction measured at two different temperatures which are differing by a 10 Kelvin. In simple words, if I have to say, means in 50 Kelvin, for example, you have done a reaction and you calculated the rate constant. and in 60 Kelvin you have done one more reaction of the same part, same reactants, and you have obtained K2. Then of course whatever the rate constant you have obtained in 60 Kelvin divided by the rate constant you have obtained in 50 Kelvin, that ratio is called as what? Your temperature coefficient. But here one important thing you have to remember, that whenever you're increasing the temperature of your 10 Kelvin, any reaction it would be, whatever temperature coefficient value is there, that is when you're taking this ratio, it will be nearly the value of 2 or 3. Now here is our concept. So what does the temperature coefficient is equal to 2 means? Yes, remember, for every 10 Kelvin of rise of temperature, for every 10 Kelvin rise in temperature, what happens if the temperature coefficient is 2? You have got the rate of the reaction, nearly it doubles. Yes, if we are getting a value of temperature coefficient is equals to 2, that means what? For every 10 Kelvin rise in the temperature, the rate of the reaction nearly gets doubled. That is the reason why we say the temperature coefficient as that of your quantitative effect. We are able to measure the rate of the reaction, how many times it is getting increased. Can you please help me to say what will be the temperature coefficient is equals to 3? Because we are having either 2 or 3. Yes? Yeah. Every 10 Kelvin rise in temperature, what happens? Rate of the reaction nearly triples. So this is the main scenario. What does your temperature coefficient wants to highlight? So why did I say this one? Because here again and again I am saying that whatever the temperature concept is there, it is directly related to that of your rate constant. Alva. Now the question arises that, sir, how can you say that, okay, on increasing the temperature, the rate constant is increasing? Please do remember, it is not said by me. In fact, a scientist called as an Arrhenius has given us an equation over here, which is known as Arrhenius equation. So what does that equation gives us? Let me write the equation, very much important equation. Please write it down. The rate constant K is equals to A into E to the power of minus EA by RT. Yes. So this is the one of the major important formula which will be used in your higher classes also. So according to this equation, when I analyze it, before going to this, let me give you what are the things I have used over here. So as you know, K is your rate constant, whereas A is your Arrhenius factor. Or it is also called as that of your frequency factor. Or pre-exponential factor. Alva, pre-exponential factor. This is your exponential factor. Previous alva, it is coming previous of it, before it. So it is called as what? Pre-exponential factor or a frequency factor, which will be detailed learn afterwards. When it is also called as that of your Arrhenius factor. Of course, E is an exponent, no need of it. But what does your EA refers to? Remember, it is called as the important concept, activation energy. What is it? Is activation energy. Yes. Whereas that of your R, you know, it's a gas constant. Anything else is left out? No. So A and Arrhenius factor, K is your rate constant, EA is your activation energy, R is your gas constant. So when you just analyze this equation, what you could see, e to the power of minus is there, very much important. When does an exponent is having a negative sign, means it is the inverse which will be related to that of your LHS. You have to keep in your mind that one. Hagare artha enagutte, whatever the rate constant is there, that is directly proportional to your temperature. So rate constant is directly proportional to your temperature. And what does we know? As your rate constant increases, rate of the reaction also increases. That is the reason whenever we are dealing with the temperature, we will be noticing your rate constant, which has been derived from that of your Arrhenius equation. When rate constant is directly proportional to the temperature, in this case, can you please help me? What will be the proportionality of the rate constant with respect to activation energy? Of course, it is inversely proportional to the activation energy. Remember, as the activation energy increases, what happens? Your rate constant decreases. Simultaneously, what happens? Your rate of the reaction also increases. So with increase in the temperature, what happens? Your rate of the reaction also increases, and simultaneously your rate of the reaction also increases. So you can just notice that with using this Arrhenius equation, how does it is giving a relationship between that of your rate constant and a temperature, rate constant and that of your activation energy. You can ask me, so here it is in the numerator alva, how can it will be inversely? Remember, whenever an exponent is having a negative sign, if I want to make it positive and RT by EA, then you put log at the base EE, it gets cancelled, so it will be A alva. So for example, if I am going to choose K is equals to A into E to the power of RT by EA plus tegdaga. Yes. So what happens next of them? If I put the ln over here, so K will be directly proportional to ln K is equals to A into, yes, RT by EA. So A is constant, R is constant, so K will be directly relation to T, inversely related to that of your activation energy. So this is a general mathematical form. We don't need this one. Just for your explanation, I have given it. You have to just remember, with respect to the Arrhenius equation, we are getting the concept as what? As your temperature increases, your rate constant also increases, because they are directly related. But as your activation energy increases, what happens? Their rate constant decreases. Why? Because it is inversely proportional. So this is the main theory. What does your temperature says? So temperature increases, rate of the reaction increases. So temperature increase by 10 Kelvin, and what does your temperature coefficient values you are going to get? Either 2 or 3. So if you are getting the temperature coefficient is equals to 2, what does it mean? For every 10 Kelvin rise in the temperature, the rate of the reaction nearly doubles. Similarly, if temperature coefficient value you are getting as 3 and 3 in for every 10 Kelvin rise in the temperature, the rate of the reaction nearly triples. When the question arises that how I am relating my rate constant with the temperature, it is given by that of your Arrhenius equation, which says that K is equals to A into E to the power of minus EA by RT. Okay. So what does it says? Of course, EA is your activation energy, R is your gas constant, A is your Arrhenius factor, K is your rate constant. So using this equation, we came to know as what? K is directly proportional to T, whereas rate constant is inversely proportional to that of your activation energy. So in this video, this much is enough. In our next video, a most interesting thing we are going to see that how does in a system, when you're adding the reactants, the product is formed. Another concept called as when does a chemical reaction proceed? Okay. So guys, as we said, with the increase in the temperature, the rate of the reaction also increases. So there will be always a question. Of course, we got an equation. Now when the question arises that how does your Arrhenius got this equation, then we have to understand the concept that how does in a system the reactants are giving you the product. So basically you have to remember that when does a system, whatever the system you have been taken, for example this is your system, and you have utilized two reactants A and B. Let me go in. Of course many such will be there. Of course you will be using 2 moles, 3 moles, like that many molecules will be there. A, B, like that, each and every molecules. Let me take it. Yes. So what happens? So remember, whatever the rate of the reaction is there, whatever the rate of the reaction is there, it is directly proportional to that of your number of collisions. Number of collisions which will be happening between that of your reactant molecules per second. So this rate of the reaction, what is this telling you? It is directly proportional to what? Number of the collisions per second. That means what? You ಎಷ್ಟು ಜೋರಾಗಿ ಗುದ್ದಾಡ್ತಾ ಇದ್ದಾವೆ ಅದ್ರ ಮೇಲೆ ಏನಾಗಿರುತ್ತೆ ನಿಮ್ಮ rate of the reaction depend ಆಗಿರುತ್ತೆ. Then how does it takes place? Remember guys, ಎಲ್ಲಾ collision ನಮಗೆ product ಕೊಡೋದಿಲ್ಲ. You have to remember what? Each and every fighting is not a licensed fighting. Alva? There are some Romeos, there are also some WWE wrestlers. Of course, when a WWE wrestlers fight, they will be getting the money. When this road fellows will be having a local fight, they will be getting what? Police ka danda. Alva? They will be getting a thrashings from the police. But in fact, here also the same concept you have to remember. What is it says? When you are taking a system and it is consisting of your reactant molecules, of course, in order to give the product, what happens? The collision between that of your reactant should take place. Yes. But remember that whatever the collision which is happening in the system will not directly give you the product. Why I am saying it? Because if a reactant on collision has to give the product means that reactant should possess some minimum energy. Okay, that is what I am saying. If I am taking an example of A and B as your reactant, if A and B on collision has to give you the product means what? Your A and your B should have some minimum energy within them. Okay, that minimum energy which leads to collision and then gives you the product, that minimum energy is called as that of your threshold energy. What it is called as? Threshold energy. Okay. So whatever the minimum energy which will be possessed by your reactant molecules, which on collision gives you the product, that energy is called as what? Threshold energy. But do remember, when you are taking a system of such reactant molecules, all those molecules will not be having that threshold energy. You can ask me, why sir? Because if any one of the molecule is having, other will also have it. But remember, this threshold energy is coming by your mutual collision. If you remember the elastic and a non-elastic whatever collisions, what happens if you are having I will take two footballs over here. Yes, this will be a great example. So if football A was static and football B you have kicked it. Okay, what happens if the football B hits this A? What happens? Whatever the energy was within A that has been transferred to whatever the energy which was in B, that will be transferred to as soon as it collides with A. Then what happens? This B will rest over here. Alva. If the same case, in case of our molecules, here I choose that the football A was static. But if this A was also moving and you have kicked your B, then what happens? Of course, it was having some energy. So when this B also collides with A, it will be having some extra energy. But what happens to the B? It loses some of its energy. But of course, once again, another football, if you kick, it will be obtaining the energy. That is the reason I am saying that if a collision happens and it has to give you the product means that reactant molecule should have some minimum energy, which is called as that of your threshold energy. But do remember, whenever you are considering your system of your reactant molecules, there are two types of the molecules having the energy. That is, some of the molecules will be having that of your threshold energy, and the other some sort of molecules will be having an average energy. Of course. So what happens? These average energy molecules will try to acquire some extra energy. Will try to acquire some extra energy to get that of your threshold energy. To get that of your threshold energy. So when does this molecules gets that of your threshold energy? Such molecules will be called as what? Your activated molecules. Remember, now the molecules have got activated. And when these activated molecules collides, that collision will be called as a fruitful collision. That is an advantageous collision. Alva yake fruitful anta heltivi? It is called as what? Your fruitful collision. That fruitful collision yakanta heltivi? That collision gives you the product. So this is the main theory which is happening to that of your reactant molecules within a system. Once again I will be saying, remember, whatever the reactant molecules you have taken, in order to give the product, they have to collide between themselves. But whenever the collision takes place, you have to keep in your mind that each and every collision does not give you the product. Because in order to give a product, the collision should happen as a fruitful. And to happen as a fruitful collision, what should be? The molecule should have a minimum energy, which is called as that of your threshold energy. Of course, each molecule will not be having such threshold energy. So what they will do, they will try to acquire some extra energy. And when thus they acquire that extra energy, they will be obtaining the overall energy as threshold energy. And such molecules will be called as an activated molecules. And these activated molecules, when they undergo collision, you will be getting that of your product. So this is the main scenario which happens whenever you're taking a two reactants in a system. Now the question will be arising, so what is the relationship between that of your temperature and with this system? Remember, of course we know that, for example, if you are standing a static and some fellow coming runningly and he dashes you, of course what would happen? You will fall. That means what? Whatever the molecules or whatever that person was having, the energy that has been transferred to you. Yes, so that is the reason you have fallen. But if I take a system, yes, of course what did I come to know? That your molecule should acquire some threshold energy to get rise to on collision to give you the product. If I am going to increase the temperature, I said that the rate of the reaction increases. Then how does it taking place? Of course, by this concept we came to know that your number of the collision increases, rate of the reaction also increases. So that is the concept over here. On increasing the temperature, what is happening? The collision between the activated molecules increases. So as the number of the collisions increases, what happens? Of course, whatever the temperature you have supplied, that will be acting as what? Extra energy for your average energy molecules. And easily they will be converted to activated molecules. And when such activated molecules increases, of course the collision increases. And on increasing the collision, what happens? The product will be favored at a greater velocity. That is, you will be obtaining your product at a faster rate. So this is the concept. What happens when you're increasing the temperature? The number of the collision between the activated molecules. Remember, the number of the collision between the activated molecules per second increases, and that is the reason the rate of the reaction also increases. By utilizing this concept, the Arrhenius was able to give his equation that your rate constant is directly proportional to temperature. So in case if I am going to plot a graph and explain you that what is happening if your molecule is having an average energy, why it is not possible for the average energy molecules to give you the product, it is similar case. If I take this one as my potential energy and this one as my reaction coordinate, okay. Of course this graph is well familiar for you. This is your graph, yes. So whatever the distance is there, this part if I take, so this is called as what? Your activation energy. Now by utilizing this graph, let me explain you whatever I have explained now, very much important. So if your molecule, of course we know your reactant is this one, this is your product. So what happens if a reactant has to convert to the product? It has to cross this barrier. Okay, this is called as what? Activation energy. Remember, as your activation energy increases, why does your rate of the reaction increases? You got to know. So maximum energy ಬೇಕಾಗುತ್ತದೆ ನಿಗ cover ಮಾಡಿ. That was the reason Arrhenius has given you over here. What is that? your rate constant is inversely proportional to E. Okay. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ ಅವರೇಜ್ ಎನರ್ಜಿ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇಲ್ಲಿ ಉಂಟಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ಇವು ಕೊಲೈಡ್ ಆಗದಾಗ ಅಫ್ಕೋರ್ಸ್ ಏನಂದ್ರೆ ಇದಕ್ಕೊಂದು ಎನರ್ಜಿ ಬೇಕು ಅಂದ್ರೆ ಆ ಎನರ್ಜಿ ಯಾಕೆ ಬೇಕು? ಇನ್ ಆರ್ಡರ್ ಟು ಕ್ರಾಸ್ ದಿಸ್ ಬ್ಯಾರಿಯರ್. ಬಟ್ ಅವರೇಜ್ ಎನರ್ಜಿ ಕೊಲೈಷನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಅದ ಹತ್ರ ಅಷ್ಟು ಕೆಪಾಸಿಟಿ ಬರೋದಿಲ್ಲ ಈ ಬ್ಯಾರಿಯರ್ ನ ಕ್ರಾಸ್ ಮಾಡೋಕ್ಕೆ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಪ್ರತಿಯೊಂದು ರಿಯಾಕ್ಟೆಂಟಿಗೂ ಒಂದು ಥ್ರೆಶೋಲ್ಡ್ ಎನರ್ಜಿ ಬೇಕಾಗುತ್ತೆ. ಆ ಥ್ರೆಶೋಲ್ಡ್ ಎನರ್ಜಿ ಏನಾಗಿರುತ್ತೆ, ಆ ಎನರ್ಜಿನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಈ ಒಂದು ಬ್ಯಾರಿಯರ್ ನ ಅದು ಪಾರಾಗಿ ನಿಮ್ಗೆ ಪ್ರಾಡಕ್ಟ್ ಕೊಡುತ್ತೆ. That is the reason we are saying that your average energy molecules will not be able to give you the product because the collision is not so effective in order to cross this barrier. Whereas that of your threshold energy molecules on what happens on collision, they will be acquiring certain energy in order to cross this barrier. Now the question arises that what is this activation energy? Alva? As I said, what did I say? If your average energy has to obtain the threshold energy, it has to obtain some extra energy. So this extra energy is called as what? Your activation energy. ಹೆಸರಲ್ಲೇ ಹೇಳ್ತಾ ಉಂಟು ಏನಂತ, ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ. ಇಲ್ಲಿ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಕ್ಟಿವೇಟ್ ಆಗಿರಲ್ಲ, ಈ ಎನರ್ಜಿ ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಆಕ್ಟಿವೇಟ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಆಕ್ಟಿವೇಟೆಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ಸೊ ಆ ಆಕ್ಟಿವೇಟೆಡ್ ಎನರ್ಜಿಗೆ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಯೋರ್ ಎನರ್ಜಿ ಆಫ್ ಆಕ್ಟಿವೇಶನ್. ಸೊ ಇನ್ ಆರ್ಡರ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಇಟ್, ಹೌ ವಿಲ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್? ಅಫ್ ಕೋರ್ಸ್ EA is what? It is the difference between your threshold energy minus that of your average energy, if I take it as E of AV alva. So basically this is your what definition anta helbodu ನಾವು, calculation part. ಅಂದ್ರೆ what is activation energy ಅಂದ್ರೆ ಏನು ಹೇಳ್ಬೋದು ನೀವು, the extra energy that the reacting molecule should acquire. The extra energy that the reacting molecule should acquire in order to get convert to the product upon collision is called as what? Activation energy. So our extra energy ಯಾವ್ದು ತಗೋಬೇಕು, the reacting molecule should get. Why they should get? In order to convert to product. And when does this product will be obtained? Upon collision. So that extra energy will be called as what? Your activation energy. So this is the concept. Whenever you're taking two reactants, or whenever you're taking a reactant in a system, you have to remember that the collision gives rise to a product. And in collisions, of course, that you have to remember, only the collision between that of your activated molecules only give rise to the product. The answer lies now within this graph. Activated molecules ಏನಾಗುತ್ತೆ, ಈಸಿಯಾಗಿ ಈ ಬ್ಯಾರಿಯರ್ ನ ಕ್ರಾಸ್ ಮಾಡಬಹುದು. ನಾನ್ ಆಕ್ಟಿವೇಟೆಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಈ ಬ್ಯಾರಿಯರ್ ನ ಕ್ರಾಸ್ ಮಾಡೋದು ಕಷ್ಟ. ಕ್ರಾಸೇ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಪ್ರಾಡಕ್ಟ್ ಫೈಬರ್ ಆಗುದಿಲ್ಲ. So this is the concept you are learning, that how does a chemical reaction proceeds. The chemical reaction start agi product kodbeku andre, this is the concept which lies over here. Okay.